Hello students, we are solving the IB Math AHL past papers and currently we are solving the IB Math AHL May 2021 paper 2 time zone 2 past paper. Today we will be solving the question number 10 of this paper and you will be getting the links to all the previously solved questions of this paper and of the other papers in the form of playlists in the description area. So without any further delay, let us start solving question number 10. The maximum mark is 15. The flight times T minutes between two cities can be modeled by a normal distribution with a mean of 75 minutes and a standard deviation of sigma minutes. So T is a normal distribution variable with the mean time as 75 minutes and standard deviation as sigma minutes. Hence, the variance is sigma square minute square. Okay. And subpart 8. Now, you are seeing only 3 subparts. The first 3 subparts of this question 10. There are more number of subparts to this question. I have just brought in the first 3 subparts. We will be doing I'll be bringing the remaining subparts after we complete these first 3 subparts. Okay. So the subpart A says, given that 2% of the flight times are longer than 82 minutes, find the value of sigma. Okay. So whenever the percentage is given, you have to use the inverse normal function. Okay. And for using the inverse normal function, you have to know the sigma and the mean and the standard deviation. But for this normal distribution variable T, we do not know the standard deviation value. We know only the mean value. So what do? We take the help of the standardized normal distribution variable Z because its mean and standard deviation values are known. The mean value is 0 and the standard deviation value is 1. So we will be taking the help of the standardized normal distribution variable Z. Okay. And what is the relation between this Z and X, or in this case it will be T? It will be T minus mu over sigma. Okay, it is actually X minus mu over sigma, but in context to this question, I am writing T. Okay, and what is T in this case? It is longer than 82 minutes. Okay, so I'll be writing 82. The mean value is 75. Over sigma, which is 7 over sigma. Okay. Now, there is another part that we have to consider. They have said that given that 2% of the flight times are longer than 82 minutes. Now, in the inverse normal distribution function, we have to always we will be giving the probability, not the percentage. We have to convert the percentage to probability. That is, we will be dividing by 100. Simple. But it should be the lesser than or shorter than or smaller than probability, not the greater than or longer than probability. So since 2% of the flight times are longer than 82 minutes, then 98% of the flight times are shorter or smaller than or lesser than 82 minutes. Clear? So we have to take that 98% or not this 2%. If you take the 2%, you will go wrong. Always remember, when you have to use the inverse normal function, you have to go for the less than probability. Okay. So now that we know that we will be taking 98% and that is equivalent to 0.98%, let us use the calculator. Menu, statistics, distribution, inverse normal, this will be 0.98. Okay, and 0 and 1, fine, enter. So this is the z value, 2.05375. So 2.05375 using inverse normal. What is the thing? Inverse INV norm. You have to write that. Using GDC, inverse norm, and it is 0.980, 1. 0.9801, right? I hope it is right, yeah. And these three parameters are within parentheses. Okay, fine. So this is the thing. This should be equal to 7 over sigma. So sigma will be equal to 7 over 2.05375 equal to, fine, the numerator is 7, the denominator, I take the answer, okay, and enter. It is 3.4084, okay, 3.4084, which is 3.41 up to 3 significant figures. Okay. So the answer to the subpart A will be, it's not allowing me to put the dot. Okay. So 3.41 minutes. Yeah. So we have solved the subpart A and we have got 3 marks. Coming to subpart B, it says, find the probability that a randomly selected flight will have a flight time more than 80 minutes. More than 80 minutes. It contains 2 marks. So the subpart B. Probability that the flight time will be more than 80 minutes. Okay. So now that we know the sigma, we know the mu value, that is the mean value, the standard deviation value, we can use the normal distribution function and we will be using that. Statistics distribution, I'm using the normal CDF. It is greater than 80 minutes. So the lower bound will be 80 and the upper bound I can write a series of nights. Okay, and the mean is 75 and the standard deviation is 3 point, I'm taking 3.4084. I'm not taking up to 3 significant figures. Don't take up to 3 significant figures for the intermediate calculations. Okay. So it is better to take 3.4084. 4084. Okay. So, okay, fine. So this is 0.071193. This is 0.071193 using GDC and this norm CDF, I'm writing over here, norm CDF, it is 80, comma, a set of nines. I'm putting 4 nines over here because I don't have much space. And then it was the mean value was 75 and the standard deviation value was 3.4084. Okay. So you have to write this part because otherwise you're just giving the final answer. Final answer can give you just 1 mark, not 2 marks. So you have to say how are you coming to this answer. Okay. So this is 0.0712 up to 3 significant figures. 0, 7, 1 and 2. Okay. So the answer is 0.0712. Fine. Now coming to question or subpart C. Given that the flight between the two cities takes longer than 80 minutes, find the probability that it takes less than 82 minutes, given that this is the condition. So it is a case of a conditional probability. Fine. So it is a case of a conditional probability. And what is the probability that has to be found out? It takes less than 82 minutes. T less than 82, given that T is greater than 80. Okay. And this should be equal to, using the simple normal formula for the conditional probability. It is T greater than 80 less than 82 over P T greater than 80. The denominator's value we know, that is this one. We have to find the numerator's value. So this is equal to, again, menu, statistics, distribution, normal CDF. And this time the lower bound is 80, the upper bound is 82. The mean is 75, the standard deviation is, I'm taking again the same thing, 3.4084. Okay, so fine. It is 0.051193. 0.051193. Okay. 0.051193 over this value 0.071193 equal to the numerator will be this, so answer, and the denominator will be 0.071193. Fine. It is 0.719074. 0.719074. 0.719074, which is up to 3 significant figures, 0.07, 719 up to 3 significant figures. Okay, so the answer is 0.719. Okay, so we have completed solving the first 3 subparts of this question number 10. Let me bring in the remaining subparts. On a particular day, there are 64 flights scheduled between these two cities. And subpart D says find the expected number of flights that will have a flight time of more than 80 minutes. And in our trauma subpart B, most probably we had seen the probability of the flight time more than 80 minutes is 0.071193. Let me show you. It was this one over here. 0.07 probability of t greater than 80 is 0.071193. Okay, so this is the value that I have written over here, and there are 64 flights between these two cities on that particular day, and we have to find the expected value. So 64 flights, so it should be a discrete distribution, not a the continuous distribution. Flights cannot be 64 and 2 or 64.5. It is a discrete variable. Okay, and there are only two possibilities. Either the flight time will be more than 80 minutes or it will be less than 80 minutes. Only two possibilities. So, and it is because the time is a continuous thing, therefore, I'm not saying exactly equal to 80 minutes, of course. So, either it will be more or it will be less. So, we are having the discrete value 64 flights, and there are two possibilities, two possible outcomes, greater than or less than. And the probability of time of flight greater than 80 minutes is also fixed. Therefore, it is a case of a discrete binomial distribution. Yeah. So, we can write maybe flight. So, I can take F. F is a binomial distribution variable. And what are the parameters that we have to write? N and P. So, N is the number of trials, which in our case is 64. And P is the probability of success. What is success? Flight time more than 80 minutes. That is 0.07 0.071193. Okay, fine. So now we have to get the expected value. F is the binomial distribution variable. It gives the number of flights which have the flight time more than 80 minutes. Okay, so the expected value of this variable F should be equal to N times P. So it is 64 times 0.071193, which is equal to, okay, 64 times 0.071193. Enter. Okay, it is 4.55635. 4.55635. So up to 3 significant figures, it will be 4.56 flights. Okay. It is 4.56 flights. Okay. Subpart E, it says find the probability that more than 6 of the flights on this particular day, where the 6 to 4 flights are flying between these two cities, on this particular day will have a flight time of more than 80 minutes. More than 6 flights. So it should be equal to 7. The minimum is 7, or more than 7, that is the maximum, will be 64. It is a case of a binomial distribution. The lowest number is 7 flights. The highest number is all the 64 flights will be having flight times greater than 80 minutes. Okay, fine. So let us move to the calculator. Okay. So statistics, distribution, this time it is the binomial, where is it? Binomial CDF. Okay. Number of trials, N is 64. Probability of success, this 0.071193. Lower bound 7, greater than, upper bound 64. Okay. 0.169119. Okay. Okay, I haven't written this. P of F greater than 6 is equal to 0.169119. 0.169119, which up to 3 significant figures will be equal to 0.169. Okay. This is the answer, 0.169. For this subpart E. And this was the last subpart of this question number 10. So we have completely solved this question number 10. And I am Nilanjana Sanyal. I tutor IB Math ESL and HL level students from inside and outside India. And I am starting my group online math tutoring session for the students who have got admitted in grade 11. And if you are interested in joining my group online math tutoring sessions, you may contact me. You are seeing my email ID, you are seeing my WhatsApp number getting displayed. So you may contact me for more details. So thank you for staying with me till the end. And we'll meet again in our next session where we'll be solving question number 11 of the same paper. Till then, bye.